All right, so number 13 is a similar problem. P is actually on the x-axis this time, so P is at 9 and 0, and then Q is at 0 and 2. So to get from P to Q, remember that you start with P as your initial point, and you're going to Q. So you're going in that direction, so it looks like we're going to the left 9 units, and then we're going up 2 units. So this would be negative 9i plus 2j. Now we're looking for, you see these little double squiggly lines, these double straight lines, they look like a double absolute value symbol. This is asking us to find the magnitude of the vector, and this mostly comes into play in physics problems, and we can talk about more of those when we look at some of our applications. So basically what we're doing is we're trying to find in the earlier problems, we had the points and we could draw the points and then create the arrow and then just break it down into its components. Now we're given our components, and we can use that to draw an arrow, and then we can figure out what the length, what the direction of, and what the magnitude of our vector is going to be based on the components. So this is negative 9i plus 12j. So that means that your horizontal component is going to the left 9 units, and then it goes up 12 units. So this is 9, and this is negative 9 because it's going to the left. This is positive 12 because it's going up. And then here is V, and it's asking us to find the magnitude of V. So simply what we're looking for is this distance, this size. What's the size of this vector? So when you hear the word magnitude, that means that it's talking about the size of something. So if you notice, we have a right triangle here now. So we're going to be using the Pythagorean theorem for these types of problems. So we're doing a squared plus b squared to get c squared, or to get the norm or the magnitude of v. So our answer is going to be 12 squared plus 9 squared, which is 144, plus 81, which would be 325. So it's going to be the square root of 325. So let's break this down. The square root of 225, which is going to be 15. So this value equals 15. The magnitude of this vector is 15. So our next problem, we have negative 5i plus j. So again, we're going to the left, and this time it's 5 units, and it only goes up 1 unit. And we're looking for the magnitude of our vector here. So we're going to do 25 plus 1, which is 5 squared plus 1 squared. And that gives us 26. So our answer will be the square root of 26. All right, so next it says find the quantity if v, this vector is 3i minus 7j, w is negative 2i plus 3j, and it wants us to find 2v plus 3w. So all we do for these problems, now we're just doing a direct substitution. So 2v is going to be 2 times 3i minus 7j, and then plus 3w will be 3 times negative 2i plus 3j. And then from here, we distribute and then we simplify the rest of our problem. So we have 6i minus 14j plus will be negative 6i plus 9j. So the 6i's cancel and we're left with negative 5j. So it's 0. So basically it's 0i minus 5j. But because it's 0i, we don't need to put the horizontal component. All right, now we're looking for the magnitude of v minus w, and notice the v minus w is on the inside, so we'll substitute the inside part first. So we'll substitute 4i minus 5j minus, and we're subtracting everything in w, so we're going to change the signs here. So it'll be plus 3i and then minus 3j. Be careful when you're doing your substitution that you distribute that negative sign. So we simplify the inside now. 4 plus 3i will be 7i, and then negative 5 minus 3 will be minus 8j, and we're looking for the norm of these. So we're going to break it into its components again and find the magnitude. So 7i is going to the right, 7, and then minus 8j is going to be going down 8. So here's 8, here's 7. We're looking for this as our vector. So we'll do 7 squared is 49 plus 64, which is 8 squared, equals our answer that we're looking for. So 49 and 64 is going to be 113. So our answer will be, for this distance, the magnitude of this is going to be the square root of 113. In our next example, the v and the w are separate. So we find, basically, we're looking for the magnitude of the vectors. We're looking for the magnitude of the vectors individually first. So we'll have 2 squared plus 5 squared. This will be 4 and 25. This will be 29. So that's the magnitude for v. And then we need to find the magnitude of w. So that will be 6 squared plus 3 squared. And that will give us 36 plus 9. So this will be 45. So this value will be the square root of 45. And if we break this radical down, we know this is 9 times 5. So this will be 3 square root of 5 to simplify this one. So we have the square root of 29 minus 3 square root of 5 when we put those two together. Here's the magnitude of v, the square root of 29, and the magnitude of w over here is 3 square root of 5. Now, for problems like number 20 and moving on, it says find the unit vector having the same direction as v. So basically what we do is we need to find the magnitude of our vectors, and then we'll divide our horizontal and vertical components by whatever the magnitude is. So this problem is 5j, so it only has a vertical component and it's going up 5 units. And because it only has a vertical component, which is 5 units, that means that the magnitude, the size of this vector is only 5 units. It's not moving to the left or the right. So the distance of its vertical component is the same as the magnitude here. So the magnitude of this vector is 5. So now to find the unit vector, you do the vector divided by its magnitude. So if we do 5j divided by 5, that just leaves us with the unit vector, u will equal j. Because we did 5j divided by 5. We divide the vector by the magnitude, by its magnitude. So number 21, we need to find the unit vector again. So that means we start out, we need to find the magnitude and then divide both components by whatever that magnitude is. So the magnitude of our vector here is going to be 6 squared, or the square root of 6 squared plus 8 squared. So this will be the square root of 36 plus 64, which equals the square root of 100, which equals 10. So the magnitude of our vector is 10. So our unit vector is going to be our original vector divided by 10. So this will be negative 6i over 10 minus 8i over 10. And we can reduce that and we'll get negative 3/5 I minus 4/5 j. And we're doing the same here. We have b equals 6i minus j. So we need to find the magnitude. So that will be 6 squared is 36 plus 1. So this will be the square root of 37. So our unit vector is going to be 6 over the square root of 37 minus 1 over the square root of 37j. Now, 23, it says write the vector in the form AI plus BJ given its magnitude, V, and the angle it makes with the positive x-axis. So this time they tell us the length of the arrow, and they tell us that it makes a 30-degree angle with the x-axis. So we know the length of our arrow is 9, and then it makes a 30-degree angle with the positive x-axis. So here is our positive x-axis, and it makes a 30-degree angle. The length is 9, and it makes a 30-degree angle with the x-axis. So we're looking for A and B, which are going to be our horizontal components. So we can turn it into a right triangle, and now we can find the opposite and adjacent sides using right triangle trigonometry. So to find the opposite side, we'll do, this will be B, our vertical distance. This will be A, our horizontal distance. So sine of 30 is going to be the opposite side, B, over 9. So 9 sine 30 will equal B. And then for A, we'll just use cosine. So cosine of 30 equals A over 9. So 9 cosine 30 will give us A. And then we plug those in to evaluate them. 9 sine 30 will just be 9 times 1/2. So B will equal 4.5. And then 9 times cosine 30 will be 9 times the square root of 3 over 2. So this will be 9 square root of 3 over 2. I'm not sure if they say round your answer to a decimal or use radicals, but if it says to round it to a decimal, then we can just enter this in to get an approximate answer. '24, '25, you're doing these the same way as you did 23. Just be careful when drawing your angles. This one is 120 degrees with the positive x-axis, so it's actually going to take us into the second quadrant. This is 90 degrees here. This is 180. So 120 degrees will look like this. Our magnitude is 10. Our horizontal distance again will be A. Vertical distance will be B. So notice this time it'll be the A, the horizontal component is going to be negative because it's going to the left this time. So if this angle is 120 degrees, that means we're left with 60 degrees this time in this case. So in order to figure out what our A and our B are, we'll do sine of 60 this time equals B over 10, and we'll do cosine of 60 equals A over 10. And remember, whatever we get for our horizontal component, we're going to use a negative value. So this time we'll have 10 sine 60 equals B, and this is 10 times the square root of 3 over 2. So this will be 10 square root of 3 over 2 equals B, and that will simplify to 5 square root of 3. And then cosine 60 is 1/2, so we have 10 times 1/2. So this would be 10 over 2 equals A. So 5 equals A, but it's negative, so we make it -5. All right, so now looking at some of our application problems, it says a child pulls a wagon with a force of 12 pounds. The handle of the wagon makes an angle of 60 degrees with the ground. Express the force vector F in terms of I and J. So you have, let's see, some wagon that's being pulled by a child that makes an angle of 60 degrees with the ground. So here is 60 degrees. And the force that the child is pulling with is 12 pounds. And the child is, I guess, kind of tall. And here's the child's hand holding on to the end of the wagon as he walks. And he's pulling it with a force of 12 pounds. So this force of that's going 12 pounds in this direction can be broken into a horizontal component as well as a vertical component. He's pulling it up this way, but you can break it into vertical because he's pulling it up a little bit as well as pulling it in this direction. So we need to find our horizontal and vertical components. So again, we'll just use sine and cosine. Here's B, here's A. Sine of 60 equals B over 12, and cosine of 60 equals A over 12. And then from there, we finish solving and we'll get our horizontal and vertical components. Number 27 now. The two forces of magnitude, 70 newtons and 10 newtons, act on an object at angles of 30 degrees and -45 degrees with the positive x-axis as shown in the figure. Find the direction and magnitude of the resultant force. That is, find F1 and F2. So we need to find our component vectors for these two, and we're going to add them together to figure out what the resulting force is. So we need to figure out what the horizontal and vertical components of F1 is. We'll call that A1 and B1, and then we're going to find B2 and A2 for our second force. So the magnitude here is 70. So we'll use sine and cosine to figure out B1 and A1. So sine of 30 degrees, our angle, is going to be B1 over 70. And then cosine of 30 degrees is going to be A1 over 70. And then for A2 and B2, we have sine of -45 degrees is going to be B2 over, this one is 10, the magnitude of this one is 10, and then cosine of -45 degrees is going to be A2 over 10. And if we use our even and odd properties here, we know cosine of -45 will be the same as cosine of +45, and then sine of -45 means that our answer over here is going to end up having a negative value. So now we do 10 times sine 45, we do 10 times cosine 45, and we multiply and simplify these over here on this side. So I'll just write them all out down in the bottom so that we can see. So B1 will equal 7 sine 30, and A1 will equal 70 times cosine 30. B2 will equal -10 times sine of 45. And then A2 will equal 10 times cosine of 45. So simplifying these, B1 is 70 times a half. So B1 is 35. A1 is going to be 70 times square root of 3 over 2. So that would be 35 square root of 35 square root of 3. So 70 over 2 is 35. And then B2 will equal negative 10 times the square root of 2 over 2. So that will be negative 5 square root of 2. And then A2 is 10 times the square root of 2 over 2. So this will be positive 5 square root of 2. So now our resultant force is going to be F1 plus F2. So F1, if we break it into its components, is going to be 35 square root of 3I plus 35. F2 is going to be 10 square root of 2I minus 5 square root of 2J and then we just need to add these two together to get our resulting force. So our result is going to be the sum of these two. So we add F1 and F2, and we end up with 35 square root of 3 plus 10 square root of 2I plus 35 minus 5 square root of 2J. And we'll put these in parentheses. So this will be 35 minus 5 square root of 2J. So our final answer will look like